Hello. And since some of you are off to such an ambitious start, I thought I would go ahead and add a couple videos for your Module 2 lab project. It is kind of one of the larger ones and maybe a little more difficult for some of you if you haven't been exposed to this. It's something your textbook doesn't spend a lot of time on, but I feel like it explains a lot about how our seasons change and some of the variables that affect the seasons. So what I'm going to do is I'm going to stop the video and leave you with my alien head. And please keep in mind, I do teach astronomy as well as meteorology and physical science. And I am going to try to share some pictures. The first picture I want to share is the one you'll see when you open up the axial tilt sun angle assignment. If you have Word, you can download the Word copy. And if you do not have Word, you might want to download the PDF version. So what I'm going to do is, hopefully this will write, is start with the very first picture. On the hours of daylight, it is helpful to kind of find the equator, which will be in the middle, and you need to determine which one is summer and which one is winter. If the North Pole is dark, it is winter, and if the North Pole is all lit up, it is summer. And once you find the equator, every line north and south of the equator represents about 10 degrees latitude. So if you are in the Dodge City area, your latitude is about 37.75 degrees north. For this front page, it is okay just to go ahead and round that to 40. If you're in Arizona, you are going to be a little further south than us. Just get a ballpark estimate. And then the table below, just count up. I asked you to do the equator, 0, and then 30, 60, and 90. You'll notice that this top line up here, that is, it's kind of stops at 60 degrees. And that's because the lines will get really close together. And anything past that little 0 hour, anything north of that would receive 0 hours of daylight in the winter and 24 hours of daylight in the summer. The next thing I want to, let me see if it'll let me move it. There it goes, but now I got to figure out how to erase. The next thing I want to kind of briefly go over is the analemma. Some of you may have never seen an analemma before. That's fine. We know exactly where the sun is overhead at on certain days of the year. On the spring and fall equinox, we know it's directly overhead at the equator. On the summer solstice around June 21st-ish, we know it's directly overhead at 23.5 degrees north latitude. And on the winter solstice, we know it is directly overhead at 23.5 degrees south latitude. Every other day of the year, you need to use the analemma to determine where the sun is directly overhead at. So the first thing you need to do is figure out the path the analemma takes. I'm going to start up here in the summer, June, and then it kind of heads down July, August, September, October, around November, and then back into the spring. So if you kind of figure out the figure 8 pattern that it makes, if you wanted to know where the sun was overhead at, for instance, on September 10th, you would come down, you would find September 10th would be about there. You would go straight over and read it, and it would be overhead at about 5 degrees north latitude. Now, I want to work a couple of examples. I did include some videos from when I do this lesson in my face-to-face classes, but I thought this might help as well. Let's say you wanted to find the noon sun angle for February 25th. All right. Now, the way I do it is this. The overall concept is, oops, I'm not writing here, 90 minus your change in latitude equals your noon sun angle. And this isn't always clock time noon. It is highest point in the sky noon. All right. So on February 25th, if we look at the analemma, the sun, let me see if I can go back here. If we look at the analemma on February 25th, the sun would be overhead at about 9 degrees south latitude. So what I'm going to do is make a mark and just say it's 9 degrees south latitude. That's where the sun is. Now, for Dodge City, we would be up here at 37.75 degrees north latitude. So what I mean by change in latitude is the difference in degrees between where you're at and where the sun is directly overhead. We're at 37.75 in Dodge City, so that would take us to the equator, and then we'd be 9 degrees further south. So our change in latitude would be 46.75 degrees. So our noon sun angle would just be 90 minus the 46.75 degrees. And 43.25 degrees if I'm doing my math right. All right, and then towards the end, there are some maybe a little more challenging questions. So I'm going to work a similar one. It's the same concept as above. It's just that I give you different information and you have to solve for a different variable. So this question asks, what is your latitude if on October 21st you observe the noon sun angle to the north at 48 degrees? Now we're still going to use the 90 minus your change in latitude equals your noon sun angle, but I actually give you the noon sun angle. So from here, you can determine that 90 minus what is going to give you 48 degrees. So 90 minus 42 degrees would give you 48 degrees. So your change in latitude is 42 degrees. So you know from this that you're 42 degrees away from wherever the sun is. So if we have the Earth, and again, we'll go back. We need October 21st. So if we go back here and we find October 21st, it's going to be about 11 degrees south, 10.5, 11 degrees south. I don't care which one you use. So the sun would be here. I'm just going to say 11 degrees south to make the math a little easier. We know we're 42 degrees from that. So are we 42 degrees north of that, or are we 42 degrees south? Well, it says we see the sun to the north, which means we have to be south of the sun. So we would go south from the 11 degrees. We would add 42 degrees to that. And our latitude would be 52 degrees south latitude. If we were to see the sun in the south sky, we would have had to go north of that, and we would have went 11, and then we would have had to go another 31. We would have been at 31 degrees north. Most of us are probably used to living in the northern hemisphere, and so we always see the sun towards the south. a few of the questions I asked you are from a little different perspective where you would actually see the sun in the northern sky. I hope this helps. And if you have any questions, please feel free to reach out to me. Don't get discouraged. It's not as hard as you think it is.